Hey guys, let's talk about LangGraph today. So LangGraph is a framework that is devised by its parent company called LangChain. So both of these frameworks helps us to build many agentic AI applications and many complex workflows with the help of LLMs. So you can see the type of success stories with LangGraph and the type of big names that the company works with, such as Cisco, GitLab, Replit, etc. So today what we'll do is we'll deep dive into one of its core components called graph in the LangGraph itself. So let's do that first. So the term graph in LangGraph consists of three components called state, nodes and edges. Now अगर हमने ग्राफ कहीं DS या मैथ्स में पढ़े हमें पता है कि एक ग्राफ के अंदर नोड्स और इंटरकनेक्टिंग एजेस होते हैं बट LangGraph में देर इज वन एक्स्ट्रा component called state or state graph to be precise. So state is a shared data structure that represents the current snapshot of your application. It can be any Python type, but it is typically a typed or parentic based model. अब दोनों में डिफरेंस ये है कि पैरेंटिक बेस्ड मॉडल आपका स्कीमा वैलिडेशन इन्फोर्स करता है और देखता है कि आपका जो भी इनपुट फील्ड के ऊपर बेसिकली वैल्यूज आ रही हैं क्या वो उसको फॉलो करती भी हैं कि नहीं करती, राइट. So it actually enforces some restriction and some validation on your schema or your input field, but typed ऐसा नहीं करता है. After that we have the nodes. Nodes are basically Python functions that encode the logic of your agents. सीधी बात यह है कि आपके नोड्स जो होते हैं बेसिक पाइथन फंक्शंस होते हैं, आप उनको अपनी स्टेट देते हैं, उसके ऊपर आप कुछ लॉजिक लगाते हैं और फिर आपको रिटर्न में एक अपडेटेड स्टेट मिलती है. ओके. Then we have our edges. So edges are Python functions that determine which node to execute next based on the current state. They can be conditional branches or fixed transitions, right? Now, if we carefully see this diagram for a minute, we can see that we start a graph from this node called node 1 or start. Then we have this node 2, which is our story node, and we have our node 3, which is our song node, and then we finally end at our node 4, which is our end node, right? So if I input a query like tell me a story, so the graph intelligently directs the control to this node called story node. Similarly, if I tell the graph to actually tell me a song, then it intelligently directs the control to this node, song node, and finally we end at our node 4, which is our end node. Okay. So that is how you work with LangGraph. You basically define your state, your nodes, your edges, integrate your LLM, and let the magic happen, right? So now what we'll do is we'll create a simple chatbot using LangGraph and basically see that in action as well. So you can also get some hands-on experience with working with LangGraph, and you can get the code for the same in description. So we can fire up our VS Code. And we can create a new UV project. So I love to use UV because it's basically firstly written in Rust and it's lightning fast because of that. So now we can say something like create a virtual environment. We can activate the same by simply setting that as a Python interpreter. So we can do something like this. Now we can activate our virtual environment. The thing is, while learning something new or developing something, you should actually go for something that is cheap and you don't have to spend any money. So for this application, we'll use some open source LLM from Grok. So you can go to Grok's website, go to developers dashboard and create a free API key. So I can say LangGraph Chatbot and copy the API key right here. Okay, I have two keys, so I can revoke one. Now we can create a new .env file and create a new variable called grok underscore API underscore key equal to this value that we copied from Grok's dashboard. And now we can start adding our dependencies. So we can say uv add python.env. You will be needing LangChain, then LangChain Grok, LangGraph, and that's it for our starters. Okay, I misspelled .env right here. So you can see that UV is pretty faster than pip. So that's why I like using UV. Now we can instantiate our LLM, but before that, let's load our env variables. So we can say load underscore.env and call this in the root of our Python script. We can set override equal to true. And now let's load our LLM. So we can say from LangChain underscore grok import chat grok. and we can instantiate it into a variable called LLM. So we can actually call some parameters inside of it. We can specify a model and the temperature. So temperature takes in a value between 0 and 1. So what it means is the type of responses that a LLM generates for the same input differs on the value that you specify right here. So it basically, you can say it becomes more creative if you set the temperature's value to a near 1, and it's like more descriptive or very dry, or you can say very, not very dynamic if the value is near 0. So if you click on control and then left click on Chatbot, you can see that the base model that Chatbot uses is Llama's 3.18 billion parameters. But I want to use the latest model from Llama. So I can go to Grok, their playground, and actually copy this Meta's Llama 4 and paste that name right here. So now we can see our LLM in action. We can say something like response equal to LLM dot invoke. और इसके अंदर हम अपना prompt लिख सकते हैं जैसे कि hello, how are you? And then we can print our response. Okay, I can say python main.py, and you can see that we get a response from our LLM saying, hello, I'm just a language model, I don't have feelings like humans do, blah blah blah. And apart from our content, we can actually see that there are multiple other attributes that are attached to our response, which is additional quarks, response underscore metadata, etc. So whenever you work with a new framework or library, you should actually refer to their documentation, which is for the best. So you can actually search for LangChain messages and see the type of messages that you can work with. So for example, the type of message that we received right now is of type AI message. So I can actually search for AI message and see what it corresponds to. So it is used to represent a message with the role assistant. This is a response from the model, which can include text or a request to invoke tools. So you can actually see the type of messages that you can work with here. Now, let's go ahead and define our state. So as discussed, we can actually have typedict or Pydantic based model. So let me work with typedict for now. I'll say from typing import my typedict, and I would be needing something called sequence and annotate it as well. Now from LangChain underscore core.messages, I need something called base message. Now I can create my graph state. So I can pass in my typedict, and what I'll have in my state is a messages array. It would be basically a sequence of base messages. It would be a sequence of base messages, and then we have to specify reducer meaning that basically what operation we have to perform on our messages when we call this inside of our graph. So if you want to see what type of implementation this base message has, you can hover on this and click on control plus left click, and you can see their implementation in detail for every module actually present here. So now we can import something from LangGraph.graph, add messages. So this is our reducer for the time being. So again, if I want to see its implementation, you can see it takes in two arguments, left messages, right messages. And what it does is it basically merges two lists of messages, updating existing messages by their ID. So that's what we want right now. And now I've defined my graph state. Now it's time to build my node. So my node, as discussed, will take my existing graph state, do some logic on it, and update and return my updated graph state. So I can say my messages equal to the messages that are fetched from my state, and then I would feed my messages to my LLM. In whatever response that we get back, we can just return them, right? So this is supposed to be an list. So now it's time to build our graph and define our edges as well. So I can say something like builder equal to state graph. So I have to import state graph as well. State graph, and also as discussed, we have the start and end nodes from LangGraph. So I can say state graph and then my graph state. and I can actually add my node here that we just created and call it by the name of chatbot itself. Now I can have my edges here. So my starting edge would be my chatbot node. And whenever we get some response back from our node, we can actually end our conversation and start with a new fresh run. Okay. So we have defined our graph. Now we have to compile a graph. So we can call this like builder.compile. Okay. So now we have to actually invoke a graph and build that chatbot kind of loop thing. So we can say while true, we have a user's input, and if the users underscore input equal to quit, we can actually break out of the loop. Otherwise, we have something called response, basically our graph dot invoke, and we have to invoke it with a human message. Okay. So again, if we have to work with some messages, we have to import them from LangChain underscore core.messages. We have something called human message. So I can specify human message with the content equal to our user underscore input. And now we can actually see that response. We can call this the response from AI is equal to our response. Okay. So now if I call this loop, I can see that it's working fine. I get the AI message back. So now, see, there is one big issue here. So if I say I am WebHub, it responds with a message, hello WebHub, it's nice to meet you. Is there something I can help you with? And if I ask it again, who am I? It says, I'm not sure who you are. So why is this happening? I just told my AI that my name is WebHub, but it still refuses to recognize me. So why does this happen? It happens because whenever we end our conversation and rerun our graph, it does not have any context from the previous inputs. So to fix this, what we can do is we can have something called from LangGraph dot state dot dot checkpointer dot memory import memory saver. Okay. So now we can create our memory, saying memory equal to our memory saver. We can pass that to our compile method, saying our checkpointer equal to our memory. And we also have to create a config dictionary. So it has the key called configurable, and its value is again a dictionary with a key called thread underscore ID, and its value can be anything. For example, I can set it to number 1. Now I have to pass that config variable here while calling my graph with the invoke method, config equal to my config, and we can actually see the response in a nice format. So what I can do is I can say my AI underscore response equal to response messages, and the last message inside of it, we have to fetch the content from that last message, right? And now I can say I will have my AI response printed here. So now if I run this loop and I ask it to actually tell me my name after I tell my AI that my name is Weber, it should be able to answer me. You are Weber, you introduce yourself. So this is how we actually persist some state or memory to our chatbot. And this is how you can actually work with memory in LangGraph. Now it's the time to see our LangGraph Studio in action. So you can actually see that we won't be needing anything right now, such as memory saver or something like that, to actually persist our context and give that to the chatbot. LangGraph Studio does that in under the hood. My bad. LangGraph CLI, LangGraph CLI in mem. While this is loading, I misspelled the name here. Yeah. So now if we go back to our documentation and search for LangGraph CLI, you can see that in order to fire up our LangGraph Studio, हमें एक चीज़ चाहिए होती है, उसको हम कहते हैं langgraph.json का configuration file. So we can copy this and we can create a langgraph.json file in our projects directory. And we can paste that configuration here. Now we have to specify a path for our graph basically. So I can say that in my main.py file, I have my graph. So now that we have specified our langgraph.json file, we can actually go ahead and type in langgraph dev in our terminal, and that should fire up our LangGraph Studio. Now, along with the Studio, it actually exposes an API endpoint for you. So you can see that an API endpoint has been exposed for you. So you can actually use this for creating your own logic and interacting with the graphs and the agentic AI applications as well. And you can see all of the documentations being mapped here. So this is some of the cool stuff that LangGraph does for you under the hood. Let's look at our LangGraph Studio for now. We can see our graph is printed in a very descriptive manner, and we can actually interact with the graph. So if I say, hello, I'm Weber, and if I ask it again, who am I? It should actually respond me with the same message. Like, you're Weber, that's what you told me earlier, this. So you can see that LangGraph has its own memory persistent kind of thing under the hood, and you don't have to do that when you're working with LangGraph Studio. So LangGraph Studio is a very nice tool to work with when you're debugging your graph, or you want to test out your graph's features or functionalities. So yeah, that's it for today. You saw that how we created a basic chatbot for with our LangGraph, gave it some memory to work with, and have some context from previous inputs. उसके बाद हमने देखा कि हम LangGraph Studio कैसे यूज़ कर सकते हैं. उसके अलावा उसके साथ हमें कौन कौन सी API पॉइंट्स मिलते हैं, आप उसके साथ उसकी डॉक्यूमेंटेशन भी पढ़ सकते हैं. So this is all the work that can be done with LangGraph, and this is just the beginning. In my upcoming videos, we will be discussing some complex workflow patterns that we can work with using LangGraph. It includes many various design patterns. There are, I guess, 4 or 5 patterns that we will be discussing. So this is all for today, and I'll see you guys in my next video.